All right, so the warm-up questions. Here we have two circuits. We'll start with the one on the left. And this one's simply asking us to find VR1. So what is the value of VR1 right here? Okay, so let's take a look at what we have here. If we see that it's one loop, and we see everything is in series, and we notice we have one battery source, V of S, and we're trying to find one voltage value. To find this, we'll go ahead and use a, what are we going to use? You can use a KVL on it. Yeah, we can do that. Or the thing is that, do we know what that voltage is yet? Not quite. And to do the KVL, we would have to do, we would follow our loop here. So we would do minus V of S plus VR of 1 plus VR of 2 is equal to 0. We just don't know the two voltage values yet, so we would have to do I R1 plus I R2 is equal to 0, then minus V of S. But then we don't know the current yet, so then we'd have to go find the current. So there's a lot of extra steps we have to do if we want to do a KVL. And I see we have a suggestion to do voltage division, and let's see how much quicker doing the voltage division is. So if we wanted to find VR1, all we have to do is say R1 over R equivalent times V of S, which will be R1 over RS times Vs, which will just be R1 is 4 kilo ohms. R of S will be equal to 4 plus 7 kilo ohms, and we'll multiply it by the voltage, which is 15 volts. And I forgot to grab my calculator, and I'm the best SI in the world. Technical difficulties here. Divided by... Okay, and this should give us 5.45 volts for VR1. Okay, and as a quick practice, you can do VR2 as well, which would be R2 over 4 plus 7 kilo ohms times 15 volts, where R of 2 is just 7 kilo ohms. And this will give us 9.55 volts, which, if we added those two together, would give us 15, which satisfies the conservation of the voltage. All right, let's take a look at the right-hand side. So the right-hand side, we have what appears to be parallel. And we have a current source here. And notice they define our currents for us here. So IS and then IR1, IR2. And they ask us to find IR2. So if we want to find IR2, what we'll need to do is use our current division, because we see here that current is going to leave, come this way, hit this point, send some down here, travel through this way, send some that way, they'll meet back up and combine to form the loop again. So to find IR2, we will say that it's going to be R equivalent over R2 times I of S, which if we break it down a little bit more, will be R parallel over R2 times I of S. And if we look at our knowns here, we know I of S, we know all of our resistor values. So we know that, we know that. We just don't know our parallel yet, but we can find it by saying these two combined is going to be R parallel. And luckily, we only have two. So we can say R parallel is going to be R1 times R2 over R1 plus R2. And that will be 8 times 6 over 8 plus 6. Which will give us 3.42 kilo ohms. Okay. So now we can just go and plug in our equation, and we can say IR2 is equal to 3.42 over R2 is 6, it's kilo ohms, times I of S is 7 milliamps, and this should give us 4 milliamps for IR2. If we look at IR1 just as a check, we can say 3.42 kilo ohms over 8 kilo ohms times 7 milliamps. This will give us 3 milliamps for IR1. And if we go do a quick KCL on it, so this is IR2, this is IR1, this is I of S. We see that 7 comes in here, 4 goes out, and then 3 goes out. 7 is equal to 4 plus 3. So that satisfies the conservation of current. Okay. So those are just a couple quick warm-up questions with a pretty thorough explanation. Does anyone have any questions about the warm-ups before we move on to the longer problems? Okay, I'm seeing none, so I'll